Hi there, this is my English speaking practice and I'm gonna solve problems on LeetCode. And today I start with this problem, multiply strings. Yeah. Given two non-negative integers num1 and num2 represented as strings, return the product of num1 and num2 also represented as a string. You must not use any built-in big integer library or convert the input to integer directly. Oh, I see. Let's create a file. September 27 multiply. So yeah, so we just multiply with values, but we cannot use conversion of input to integer directory. So I have no idea about this, how to calculate the product of them. Okay, got it. Maybe we should calculate for each digit, right? So we cannot convert it directly, but we can convert the character for each digit to integer. Yeah. So and also the length of numbers might be 200. So yeah, it's gonna be overflow, I think. But Python's integer can handle numbers, any numbers. Yeah. The integer in Python can handle arbitrarily large numbers, can handle numbers of any size without limit. But we cannot use direct conversion. So the strategy is to calculate it for each digit. Yeah, so we have to align the digits. The length of numbers might be different, so how to Yeah, so I will go from the ones digit, ones place. So for example, 23 times 2. Oh, I see. Like this. But how about this? We should calculate 1 times 5. Yeah. I see. So in this case, we fix the one digit first and go through the other numbers like this. And then we move the number, the digit, and that is like this. Yeah, and finally we sum up these numbers. That's a product. That makes sense. So just use double loop and number 1 and yeah, but Yep. The first number should be num1 and rem num1 minus I, because we want to go through from the end. That's the ones place, ones digit. So yeah, so this start with 0, so we adjust the indices like this. Yep. And also times digit. And likewise for number 2, yeah, initialize the digit for B, and the B is like this. And but wait. We don't need to calculate, we don't need to include digit in calculation, because we can make it without digit. And if I use digit, the digit can be up to 200 zeros. Yeah, so that's too big. So I think this is not good. This is not good. But I need to manage the digit for calculation. Yeah. So the how to do that? So in this case, 200 and 2000. And digit 1, digit 2, digit 3, digit 2, digit 3, digit 4 in this case. So yeah, we can remove zeros. And we have a number. Ranges from 0 to 9 and digit, and its digit. So in this case, 5, 7, 7, 2. So the answer is 2775. Yes, 2775. That's correct. So we can use this logic. Yeah. So hmm. How to decide the digit? In this case, the digit 1 and digit 1, and the result is 1, and 2 1 is 2, 3 1 is 3, 1 2 is 2, 2 2 is 3, 3 2 is 4. So we can just adding them and minus 1, that's a digit. So and this result might be carrying up, so we should take it into consideration. But yeah, the basic logic is like this, and we make digit numbers, and after that we are building answer strings, and digit numbers and items. We can get key and value, and the key is carry. Yeah, so we don't care about the keys, just get values, and value yes, and v plus carry and divide by 10, and the remainder gonna be the answer as a string, and the q is a new carry. Quotient is a new carry, right? And finally, if carry exists, oh wait, we append the number from the end, so the string should be reversed. So reverse and concat them for building strings. Yes. I see. What? Really? 1, 2, 3, 5, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, I cannot add a digit. So in this case, yep. Somehow close, but why this is? 18, 15, 12, 12 plus 12 and plus 10 and the 8 and 6 plus 6, nice, and plus 8 and plus 5 and plus 4, so the dict is good. So digit numbers are calculated correctly. Yeah, so we should review this part. Digit numbers values and maybe we didn't care about this, and the value should be like this. Oh, same. Wow. 18. 18. So the 8 is appended and the carry should be 1. 8, 8, 0, 8, 8, 0. Oh, 88065. That's good. Salt, not salt. We should reverse. Good. So submit it. Wrong answer. 000. Yeah, of course we should handle good, but it's slow. This is not. I think this is not good. I think so. Yeah. Yeah, I'm proud of this solution. Yes, and let's move on to the English reviews. But before that, I want to add comments in English for reviewing. First, we define hash map for storing products for each digit, and this digit is for one, and we have to go through nums, which is the smaller digit. Digit is for num2. Yes. We are not allowed to use conversion. So we are gonna calculate digit by digit. Increase digits, which means 10 times, multiply 10 times, and we take the there might be carry. Yeah. Okay, let's go. You avoided using direct int. You correctly went digit by digit. Went digit by digit from right to left. Carry correctly. Worst one. Points to improve. Yes, adding more expressions. Yeah. First, let's handle a quick edge case. If either number is 0, the product must be 0. We are not allowed to just convert the strings into integers, so we'll simulate manual multiplication. Basically the same way we do it on paper, digit by digit. Basically the same way we do it on the paper, digit by digit. We'll use a hash map where the key is the digit position and the value is the sum of partial product for that position. Yeah, I like this sentence. We will use a hash map where the key is and the value is okay. Value is sum of partial product for that position. Partial product. Now let's go through each digit of number 1 from right to left. For each digit in number 1, we also go through number 2 from right to left. The digit position in the final number is basically and add the product into the corresponding digit position. Move to the next digit. Now we need to build the actual number from our hash map. Add carry to the current position, then split into quotient and remainder. R becomes the digit at this position and Q becomes the new carry. If there is any carry left over, we add it and as the highest digit. Finally, we reverse because we built a number from least significant digit. Yeah. Build the number from the least significant digit. From the least digit. Okay. We simulate manual multiplication just like we do on paper. We store immediate product, intermediate product into a hash map keyed by digit position. Once we built up all the partial sums, we process them with carry to form the final number. We reverse. These are good phrases. Yeah, I hope I can say like this. Once we build up all the partial sums, we process them with carry to form the final number. We reverse at the end because we built a number from the least significant digit upward. From the least digit upward. That's okay. That's good. Okay, nice. Nicely done. Next. Jump game. Oh, I didn't solve it. Oh, anyway, let's do that. You are given a zero-indexed array of integer nums of length m. You are initially positioned at index 0. Each element nums I represents the maximum length of a forward jump from index I. In other words, if you are at the index I, you can jump to any index I plus j, where yes. So return the minimum number of jumps to reach index n-1. The test cases are generated such that you can reach index n-1. That makes sense, and I've solved. I solved on the way. I'm on the way. I think. So in this case, 2, 3, 1, 1, 4, and I'm at first index 0 here, and aim to go to last index here, and the minimum number of jumps to reach the last index is 2. Yeah, because we can jump to here or here at first, and in order to reach to there with minimum jumps, we choose here because we can jump 3 from here. So jump here and jump to here. So the number of jumps is 2. The answer is 2. Same way, yeah. So let's take a look at the current implementation. we need to find the minimum jumps to reach to the end. In this case, we have the range to jump. Yeah, that's right. And we have counter and max index. Max index means the position where we can reach. We can reach the maximum position where we can reach. So at the time. So in this case, if the max, if the I plus number at the I is greater than max index, that means we can go further at the time. So the yeah, so in this case we had better jump, so the counting up and the max index, update the max index. Yeah, and if it's at the end, we return the counter. Yes. I think this is good. But I haven't submitted. Let's test it. Good. Wrong answer. Yeah. Yes. I see. The max index might be more than end index. So yeah, we should check condition like this. Really? Seven means 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, I was wrong. Okay, I was wrong. So this is kind of greedy. So in my current solution, I'm going to here, but after that we reach to here, and the max in this index gonna be here plus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that, we reach here and we can reach the goal. But the counter is, counted at this time. So the answer gonna be wrong. So we shouldn't you shouldn't count. There is a time we shouldn't count. So maybe I should use dynamic programming to manage the minimum jumps. So I want to define let me define the sub what is the minimum jumps to reach ice press? So the mean jumps so initialize the mean jumps with a large value, and we are going to update this. For example, in order to reach to zero place, zeroth place, we can achieve zero jumps, right? Okay, so this is a core concept, and after that we can use jump. We can jump. So we can jump. So jump range is oh wait, but we have range. So how to update the okay, the naive solution is like range nums I and min jumps I plus j is right, because from the I position we can jump j, so the jump number is incremented by 1, and we can reach position at I plus j with this number of jumps, but the number range is to 1000, so this loop gonna be how to say 10,000, and this might be 1000, so that's not good. Yeah, it's gonna be 10 million loops, so it's slow. But I'd like to solve this case. Yeah. And in this case, we focus on the maximum index. And we don't count how about this? In this case, yeah, I think this works because we store the minimum jumps here and it start with 7, so we can go there at first and the minimum jump is updated. Okay, updated 1. Okay, 0 and too big value, and too big. At first, and 0 and 9. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can achieve. Oh, but I should have update here to 1, and this gonna be 2. But how to update here? Because yeah, in the naive solution we can update all of them because we have a range. Yeah. Right. Okay, so how about use a new variable, because that's not good. Current jumps in this case. that's not good. Oh my god. Let me try this solution. Index out of range. Hmm? I see. Oh, but it's too slow, so okay, let's see this solution. Near and far end jumps is initialized with 0, and far is until the far reaches to the end. Process it. And near to far plus 1. and farthest. So at first the loop is gonna be 0. Loop once at first, and the number at the position 0, and zero plus jump ranges, and determine the farthest. After that, update near. It's just move pointer and update the far to farthest. So the next is far to farthest. Near. 000 and 177. Mm, 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 mm. Mm, mm. So the basic idea is to determine the farthest position and determine the farthest position by one jump. And at the same time, so in this case, in the second jump, we go through these lengths, these ranges, and determine the farthest. One, two. So in this case, in the first jump, look at here, and the farthest gonna be here. And in the second loop, the farthest end far is here, so the go through this range and determine the farthest. And at here we can reach to here, so the answer is second. Answer is 2. I should have come up with this idea, but I couldn't implement it. Yeah. So the max index means farthest, and if it's I see. So in this solution, with one jump, we can try many attempts to determine farthest position, because we have a range. But in this solution, we loop we loop one by one, and every time the farthest position is updated, we incremented the jump counter. Yeah, that was not good. Because we should determine the farthest in one jump. So in this case, the first jump just look at 7, but the second jump we can look at these lengths, these ranges. So 0 and 9 and 6, 9, 6, 1, 7, and so so this is the difference. Okay, I understand. Okay, I'm tired, so I got tired, so let's finish.